Good afternoon, my name is Kevin and I'd like to demonstrate the oxyacetylene welding and cutting system. Here we have a complete oxyacetylene system set up already. It's securely fastened with a chain to the cart. All oxyacetylene systems should always be secured at all times. Your oxygen bottle holds pressures in it from 0 to 3,000 pounds per square inch, and your acetylene bottle will hold anywhere from 0 to 300 pounds. Your acetylene bottle is filled with an asbestos material, and acetone is injected into the bottle. Small bubbles are formed inside the bottle to create the acetylene gas. Here we have the regulators already set up on the valves. The oxygen regulator is made from brass. There's green is usually your oxygen color code. Your oxygen regulator has a right-hand thread, so it screws onto the valve with a right-hand thread. Your acetylene regulator is also brass with a reversed thread, so it'd be your left-hand thread goes onto the acetylene tank. That way you can't interchange one with the other. The acetylene regulator will not attach to the oxygen bottle. All regulators and all components are made from brass because the fittings are metal-to-metal fittings, and that will eliminate any kind of spark. That's why they're made from brass. Each system comes with flashback arresters or reverse flow check valves. These are located here on the regulators and also on the torch body, here and here. What these flashback arresters do is they eliminate any flow back into the system. So if your torch attachment breaks or you have a fire in this direction here, it will not go any further than these reverse flow check valves. Now if you have a rupture or a line or a hose on fire, it will not continue any further into the regulator up until the reverse flow check valves, here and here. Now to turn the system on, oxygen bottles are always turned fully on. On these regulators there's gauges that will show your tank pressure and your working pressure. For your acetylene tank, it's 1/4 to 1/2 turn. The reason for the 1/4 to 1/2 turn is to eliminate any draw of liquid acetone from the bottle. Also, it's a safety precaution to have it 1/4 to 1/2. In case of an emergency, you have to quickly shut the bottle off. It's just a quick shut off. So 1/4 to 1/2 for your acetylene, fully for your oxygen. Now that we have the valves open and the pressure to the regulators, I'm going to give it the working pressure to the torch. That is done with the adjustment screws here. For the oxygen, I'm going to bring the oxygen up to 40 psi. That'll give me 40 pounds per square inch working pressure to the torch. For the acetylene, I'm going to bring it up to 8. That'll give me 8 pounds. Now the system is pressured up right to the torch. Then I'm going to give it a leak test. This leak test is done with a non-detergent soap and water. You simply just spray it all over your components and your fittings and look for bubbles. Now if there's no indication of any bubbles, your system is secure. Now if you see any bubbles, you will have to come back with a wrench and fully tighten them up and then give it another leak test. These attachments will unscrew off the torch body by hand, and I could take this cutting attachment off. Now if I'm going to braze or silver solder, they have attachments that range from 0 to 5 for my oxyacetylene brazing and silver soldering. They just screw on hand tight to the end. Now if I'm going to straighten out any heavy pieces of steel, I would use something like this. This is called a rosebud. The rosebud just screws on the end just like the other attachments. But today we're going to be using the cutting attachment. So it's just hand tight, back on, brass to brass fittings. Now to start the system, I'll be using a striker. It's a flint striker, and that'll start my flame. There are 3 different types of flames. There's a neutral flame, an oxidizing flame, and a carburizing flame. Always have your safety glasses on at all times, and when you're cutting and using the flame, I use a number 5 shade. Always wear gloves and always protect your body and skin. Now to turn the system on, I'll use my striker and I'll turn my acetylene valve on. I'll get the flame going and I'll introduce the oxygen. I'll bring it in to what we call a neutral flame. I'll depress the lever. That is your neutral flame. That is your cutting lever. That's what cuts the steel. Now to bring it to an oxidizing flame, I'm going to add more oxygen. You'll hear it hiss. The flame will change color, and that high hissing sound indicates more oxygen than acetylene, which gives me an oxidizing flame. Now the reverse, I'll bring it back to neutral flame and add more acetylene. Now you can see it feathering out on the flame. This would be called a carburizing flame. Now I'll bring it back to a neutral flame. And to shut the system off, you shut the fuel valve off first. Like so. And then shut your oxygen off. Now to bleed the whole system, to completely drain the lines, you shut off your bottle here. And your acetylene bottle. And then depress the lever, turn your acetylene valve back on. I'll watch the gauges go down to 0. Once they're all at 0, I know the system is completely bled and drained. I'll shut off the valves again and back off my adjustment screws so there's no pressure on the regulators themselves. And that's your safe operation of an oxyacetylene system. Thank you very much.